Good morning. So as Steve said, my name is Monica Wilson. I am the Florida Sea Grant representative of our team. I'm located in St. Petersburg, Florida. And I'm going to speak to you a little bit about the Deepwater Horizon, what happened, and where did the oil go. So I'm going to give a quick background on oil. I'm going to show a video of the Deepwater Horizon that was produced through a partnership between Gomery and ScreenScope. And then I'll talk a little bit more about where the oil went and some of the impacts that it had on the shorelines and the wetlands in Louisiana and beaches in Alabama. So just a quick background. As we all know, oil is a multi-purpose item, and it's used for our transportation, in our homes, and it is part of a lot of our products that we have and use in our daily lives. So oil is made of many compounds, and obviously we have a lot of different types of oil, but we're just going to briefly discuss this just because due to time constraints. So the compounds that are found in the oil obviously dictate, well, it can be used as a chemical fingerprint, and it dictates the location of where the oil came from and how much refining is needed. We have light versus heavy oil. Light oil has smaller carbon molecules, it flows a lot easier. Heavy oil has bigger carbon molecules, it's a lot gooier, floats on the water. Those are just a few distinctions, but just also depending on what kind of chemicals and elements are found in the oil can also dictate if it's a sweet or crude oil. So there's many different types that I cannot necessarily get into too many details about, but just want to introduce that to you. And these impurities that are found in the oil are what makes the oil needing refining, basically taking out all these impurities to help make, to get all these elements that are not wanted in the oil out of the oil. They call it refining. And oil, as most of us know, can be weathered due to sunlight, heat, microbes, and oxygen. So back to the global perspective of oil, a little bit more than half of the oil found is due to man-made activities, either through consumption of petroleum, transportation, or extraction. Almost half of the worldwide oil is due to natural oil seeps. And these seeps come out through through cracks and faults located in the earth, and that's how they enter the marine environment. A lot of microbes and animals that live on the seafloor have become very used to having this oil around and actually use it to produce food for themselves, and is actually, they've basically have been able to take the oil and help themselves with it by using it as a food source. And right now, the latest numbers show that in the Gulf of Mexico, we have over 900 plus natural seeps that are occurring right now. And just to let you know, as Steve said, we have a lot of publications, so throughout my presentation you will be seeing this little sign that says read the publication. That means that we've actually produced a publication a little bit more on this topic. So if you want to know more, again, Chris can help get you some of these publications. They're located online at on our website, so you guys can also read them, download them there as well. So now I'm just going to show you a quick video, like I said, about the Deepwater Horizon. It's about a 2-3 minute video that gives you a little bit of background of what happened during that time, gives you some of the statistics that happened, and was produced by ScreenScope, who was partnered with Gomery to produce this documentary.
I got a phone call from a friend of mine who works for the government, and he said, you have to get involved in this spill.
It happened on April 20th, 2010, 41 miles off the coast of Louisiana.
It's going to change your career. It's going to define every part of the rest of your life. You have to get in the game and get down here.
Tragically, the explosion killed 11 and changed the lives of millions living near the Gulf Coast, as well as hundreds of scientists who responded to the crisis.
I was as close to the well as any scientist could be. This cauldron of oil that's flying out of the bottom of the ocean floor.
4 weeks after the BP Deepwater Horizon disaster, oil hit the Louisiana coast.
The first few days of the major impact, it was mind-boggling. Everybody just could not believe how much oil was on the beaches.
In an effort to break up as much oil as possible, almost 2 million gallons of dispersants were sprayed onto the surface of the water and directly into the escaping oil. By the time the well was capped, 87 days after the blowout, hundreds of communities and millions of people were affected.
We smell fumes from oil. Is it safe to stay here and breathe? Can we get in the water? Can we walk on the beach?
People were looking for answers, and I think that that was a very difficult time because we were still trying to research and uncover what had truly happened.
This was really a catastrophic disaster, but it was, from a scientific point of view, this is an incredible opportunity to really understand how the ocean responds, how the system really functions.
What ran through my mind first was, let's go out and get some baseline data, at least have some measurements about what was there before the oil.
When I heard about the oil spill and I realized that the blowout occurred at 1,500 meters deep, I knew that we didn't have any baseline data for the large fishes in that area.
To discover what happened, scientists from around the world turned their attention to the Gulf of Mexico.
A whole research community has developed.
It's composed of engineers, it's composed of chemists, biologists.
We all get to work on pieces of this very big puzzle.
We're trying to see if we could come up with new, unique methods to understand the oil pollution process.
In controlled experiments that we perform in a laboratory, we try to answer these questions.
Every dive, I've seen something new that I didn't know before. We discovered processes and organisms and microorganisms that are new to science. I mean, good grief, how incredible is that your job is to discover things that no one's ever seen before.
Today, an international team of researchers are focused on the Gulf of Mexico. These are some of their stories. Intimate portraits of research, innovation, discovery. Stories that speak directly to a nation still recovering from the largest oil spill in U.S. history.
As it said in the film, this Deepwater Horizon occurred April 20th in 2010. 11 people were killed and oil flowed for 87 days. So now I'm going to go ahead and talk a little bit about where that oil went and how emergency responders responded and what techniques they used. So this is a map that shows, it was from NOAA's Emergency Response and Management application, and basically it shows where the oil went. It's not a cumulative amount, it's the dark. As the gray areas get darker, that means that area was oiled for a longer period of time. So this is not showing where oil was all at one place. So what we can see is that by the wellhead, you have the darkest colors, meaning that oil was flowing there for the longest period of time. But this just gives you a picture of where the oil went and what areas were impacted at that time. Approximately 100, so the estimate is, scientists estimated that 200 million gallons of oil entered the Gulf of Mexico. However, some of that was recovered on the surface, skimmed out, or burned, and so they estimate that approximately 170 million of those gallons of oil actually entered the Gulf of Mexico. So just a little bit on the tools and technology that have been used to study this oil spill. There's been computer models. We have satellite imagery that's been used. SAR images, which is a radar that's attached to satellites and planes that can take pictures of the surface of the water and point out where oil has been located. We have AUVs that I've seen, and as we saw in the video, ROVs and HOVs like Alvin, the human occupied vehicles were used to, all of these technologies were used to have been used and are still being used to study the oil spill. So just a quick background on the modeling. So this is a picture, a graphic from scientists at the University of South Florida. This is a picture that they produced from the oil that they started this prediction on June 10th and ran this model for 3 days. So here in this is where the wellhead is. The pink depicts where the oil was on June 10th. They then run the model for 3 days, and the black shows where it's going. So this is a tool that's used to help decide where the oil is going and help emergency responders predict or get to an area where they think oil might be coming, to be prepared to see how the oil is going to be and what response tools they might need if there's protected areas in that area that they need to protect. And so also these gray lines indicate currents. The length of the arrow is the strength of the current. And as you can see, we have the loop current here. And if you don't know, the loop current is just a warm current that comes through the between Cuba and the Yucatan Peninsula. It then goes into the Gulf of Mexico and comes right back out and heads out through the Florida Straits. And one of the initial, one of the initial emergencies that the responders were thinking about is that if oil entered this loop current, then there was a possibility that it could be hitting Florida Keys and Cuba. So that was one of the initial things that the scientists were worried about. And so we had a few scientists actually monitoring the loop current, and this is from scientist Dan Walker. And again, here you see the loop current. The colors in the background are just sea surface temperatures. We have the oil here, and we have an emerged cyclone. And as we saw, there is some oil that actually entered this emerged cyclone. And so what the loop current does is, as it goes, it tends to shut off these eddies. And these eddies are the ones that spin out and possibly can bring oil down to the Florida Keys or to Cuba. And so that, again, was the initial worry of the folks in Florida. Was oil going to hit the Florida Keys, which has also a marine national sanctuary. So if that was the case, they were going to have to start thinking of new response on how to protect that area. So NOAA, again, here's another publication. It just came out, predicting the movement of oil. Has more both of these studies that you guys can read about if you want to know more details. And due to that fear of oil getting into the loop, into the emerged eddy, NOAA was producing maps on a 24 hours, 36 hours, 72-hour basis so they could keep track of the oil. They were using their model to keep track of the oil, and this is just a picture an example of where the oil was on May 20th. What they ended up finding out is that although there was some oil that got in one of those eddies that spun off the loop current, luckily that eddy stayed stranded for months. It didn't move, and so no oil actually ever reached the Florida Keys or Cuba. So this is just another video. So as I mentioned before, scientists use SAR data imaging to create these pictures of where the oil went and how much went. And this is a video, an animation that came from those SAR images. So scientists took over 166 images from this device, and they compared them daily to see where the oil went, where it was, and then after response techniques. So if they knew that emergency responders were applying dispersants on one day, they would compare the pictures to before and after to try to get an estimate of how much oil, did it really work, where did the oil go, the volume. So the colors here depict the amount of volume that's in the oil there that's at that particular moment. So again, this little dot here tells you where the wellhead is, and just as you can see, these colors depict the volumes in meters cubed per kilometer cubed of how much oil was in a particular area at a particular time. So let's talk a little bit about the response. So offshore response, they used skimmers, controlled burns, and dispersants. Dispersants were used both at the surface and at the wellhead, as you saw in that video. I'll talk a little bit about that in a second. Skimmers are just equipment where they use boom to collect oil, and they basically vacuum the oil off the surface of the oil, and it's attached to a tanker where all that oil they collect goes into a tanker, and then that gets shipped off and goes to an area where they can dispose of it appropriately. And then burning just happens when they enclose a piece of oil with fireproof boom and they light it on fire and basically get most of the oil off the surface of the water. There is a byproduct of burning that can possibly send some of the leftover products from the burn down to the seafloor. And so I was going to talk a little bit more about dispersants. And the way dispersants work is they have they're a molecule that have a side that's attracted to water and a side that's attracted to oil. And so they basically attract themselves to oil. And the whole idea of these dispersants is to get a big slick and break it up into smaller pieces or molecules that then make it readily available and able to be broken down by bacteria. And so basically you're just taking this big slick of oil, trying to break it down into little pieces so that it can naturally disperse using waves or currents, or it can be broken down with the bacteria that's already in the water. So this is just another graphic showing what was going on during the Deepwater Horizon. Again, like I said before, 29,000 square miles of oil were located on the surface, and they used 1.8 million gallons of dispersant on the surface, either by plane or by boat. And then in the water column, scientists found that there was a plume of oil at about 3,200 to 4,000 square feet, feet below the surface. And as you saw in the video, they directly applied dispersants to the plume or to the wellhead, and they used about 0.8 million gallons of dispersants below the surface, trying to tackle the problem before the oil reached the surface. And this is again the map that I showed before, but the addition to this is these lines show where they applied dispersants by plane. So it just gives you a big picture of where they're going and how much was applied on the surface. So for the nearshore response, as Steve said in his talk, there was a lot of boom that was being used to protect some of the shoreline, and again they were using skimmers, and skimmers can be used in the nearshore response on smaller boats where they again encapsulate the oil within boom and then put the skimmer in and bring out oil. Of course, it's on smaller vessels because of the location of it, but they can still use skimmers to remove oil from the surface in those areas. As for onshore response, so they sent out, the NOAA sent out their SCAT team, which is basically a group of folks that go out and it stands for Shoreline Cleanup Assessment Techniques, and they go out and assess the whole shoreline. They assess where the area is, what oil came up, are there any historical sites or archaeological sites that need to be protected, and depending on the answers to those questions, they decide what response technique is needed. And so during the Deepwater Horizon, these three response techniques were all used. They had sifters going out there and trying to sift the sand and take the oil out. As you see here, if they saw oil, they just try to dig it out and capture as much oil off the beaches as possible, or they could go out and dig tar mats. And I'll speak about the tar mats in just a little bit as well. As far as for other emerging tools and technologies, so since the Deepwater Horizon, a lot of scientists have been trying to find other ways to combat oil spills. And so what they find is that there's a need for sorbents and surfactants and additives that are all low cost, environmentally friendly, and biodegradable. And so some of these products include microbial-based surfactants, and basically that's microbes actually produce a surfactant on their own. And so scientists are looking to see if the surfactant that these microbes produce, which is naturally occurring and a little safer for the environment, if that could be used to combat oil spills in the future. And then we also repurpose everyday materials and nanotechnology. I'm not going to get into the nanotechnology, it's a little more complicated than I'd like to go into. But again, there's a publication on this that we can share with you again, and if you want to read up more on this new and emerging technology that's coming up. So now let's talk about where the oil went. So out of all the oil approximately that came up to the shoreline, there was 1,300 miles of shoreline that were affected and oiled. And so this map shows, these colors indicate the amount of oil that was found. So blue indicates no oil observed, red is where heavy oil was observed. Just keep that in mind. If we break it up by state, we see that Louisiana received 64% of the oil that made it onshore. So they saw the worst of it, and they got, it was 847 miles of shoreline that impacted the state of Louisiana. Florida, 177 miles, Alabama, 95 miles, Mississippi, 157, and Texas saw the least amount of oiling with 35 miles of their shoreline being oiled. Now, as far as wetlands go, if you look back at this map, this is mainly the wetlands in Louisiana. As you can see, we have a lot of red, meaning that it was heavily oiled. And so, approximately out of the habitats that were oiled, 52% of them were wetlands. And so, Louisiana, like I said, saw a lot of impacts from the oil on their shoreline. And it has been known that plant cover decreased by 11 to 53% in these heavily oiled Louisiana sites after the spill. So here's a couple of pictures that show the marshes before and after the spill. So if you look here, this is from Barataria Bay, where we can see a lot of red, again, from that map, so it was heavily impacted. We have a nice clean edge. After that same area was hit by oil, you can see we have these scoured out embayments. So basically, marshes can recover from oil spills depending on the amount of oiling. However, if the marsh roots, which completely keep the integrity of the marsh and the wetlands, basically the roots are the structure of the marsh. So if the roots get heavily oiled with oil, it can really impact the marsh. They no longer have structural strength, and so then you see that the marsh actually, these start caving in, and the wetlands start caving in, and then they can't reproduce and recover until either replanting or there's some kind of restoration technique put in place. So this is 2 pictures, and some scientists found that although some of these marshes were oiled, they didn't see the impacts on these marshes until 2 years after the oil spill. So it was a slow process. It wasn't a direct impact that you could see right away. This was 2 years later after the oil had already hit. As far as beaches, beaches took up 46% of the shoreline that was impacted by oil. As we can see here, this is Mississippi, Alabama. They saw the most, or that beach is what saw, that beach saw, those beaches saw the most oiling during this time. And so what happens in these beaches, on the beaches, is that as the water comes in, the oil gets deposited on the beaches. If you have a low tide, the oil can get deposited right here in this area. And then as heavy winds or rains come from storms, they can get they can get mixed up in the sand and cause these tar balls right here. Also, these buried oil mats are basically oil that sunk to the bottom and have basically been covered by sand. And again, so when a heavy storm causes high wave energy, these mats can be turned around, broken up, and then you see tar balls. So again, this is a delayed reaction. A lot of times, these tar mats were hidden. They didn't come up right away. And maybe a couple years later, if this big storm came and came through the area, tar mats would again wash up on the beaches. And when scientists fingerprinted, realized it was still oil from the Deepwater Horizon oil spill. Again, we have another publication on this topic specifically, just to let you know. So again, if you want to hear in the future, we can get them to you, or you guys can see them on our website to learn more. This is another use of the technology. So some scientists took a model to try to model these tar balls and exactly what would try to see what was happening. So in the field, like I said, tar balls were washing up after a relaxation phase of storms, and scientists were seeing this. So what they decided to do is they made artificial tar balls and put them in one of their tanks in their labs, and made 10 centimeters, 5 centimeters, and less than 1 centimeter tar balls. And in their labs, they're trying to figure out if depending on the wave action and the wind action, would they get buried, would they sink, can they be recovered? And so what they found out is that the big ones got buried, the medium ones were mobile and would come up on the surf, and then the ones that were less than 1 centimeter were hard to recover. And so they used that data to have model simulations. Again, on this side you have small waves, and these are the different sizes of tar balls, and here you have large waves. Blue indicates that there's nothing being moved around, and pink indicates that there's a lot being moved around. So what we can see is that the lighter tar balls, when there's large waves, they get moved around a whole lot. There's a lot of pink. And as you go down in size, that mobility gets less and less. So here's a graphic that we have on lingering oil. So all the oil that came on shore, we have numbers for it, but then people were wondering what happened to all the oil that remained in the marine environment. So here's a graphic that shows that by Lair et al. From NOAA and Valentine and Chanton, they came up with these numbers. So some of the oil, about 20 to 25% evaporated, 5 to 6% was burned, 2 to 4% was skimmed, and then 10 to 20% was chemically dispersed. Out of the total of the 200 million gallons of oil that came out of the wellhead, 16 to 17% of that was actually recovered directly from the wellhead. And then they just recently found out that 3 to 5% of that oil made its way to the seafloor, meaning that 11 to 25% of the oil is still unaccounted for. They don't know where anywhere from 11 to 25% of the oil, they have not accounted for it, not sure where it went. And then this is a piece of technology that was used. As I spoke in the beginning, you saw that there was a plume of oil that came under the water, and this is one of the many technologies used to actually figure out where this plume was. It's called the Sentry. And so basically what the Sentry did, this is another technology, excuse me, let me go back to here. So it's called a toyo, and what they do, it goes up and down in the environment, and it goes in a circle. So they used this technology first to discover that they found some higher levels of petrohydrocarbons here. And from that, they used the Sentry to go directly to that location. Sentry has instruments on it that can actually indicate an increase or decrease of hydrocarbons in the water. And so what it does is, as it goes through its route, if it finds a place where hydrocarbons have lowered, it'll turn around and go back to where it found the higher hydrocarbons. So basically it does a zigzag pattern. It goes, it finds an increase of hydrocarbons. As soon as it decreases, it turns around and goes back to find where that level was. And so basically they did the zigzag pattern to map out this plume of subsurface oil. And this is just an animation of what Sentry did in the subsurface. So again, there was, the oil was leaking. They found high levels of hydrocarbons using the Toyo, so they decided to put the Sentry in the water. It doesn't find the hydrocarbons, it turns around, finds some more. If it doesn't find them, it just keeps zigzagging back and forth. And these numbers are being sent to scientists so they can actually manipulate the AUV and try to find how large. And so by using this technology, they're able to see, approximately give a good idea of how long the subsurface plume was. And just to indicate, it wasn't a river of black oil just kind of floating in the subsurface. The water, there's been water samples taken from there and they were clear. You really can't see anything. It's not until you take the chemical composition and the numbers and do all the chemical analysis to it where you see the increases, or have a Sentry that has an instrument that can read these numbers on site, that they know that was there. And that's one of the main tools that they used to indicate that the subsurface plume was there. As you heard me say, there was about 3 to 5% of the oil that made it to the seafloor. And so this slide just basically shows you 6 ways that the oil gets to the seafloor. One is that it mixes with any particles that are in the water column, causing it to get heavy and sink. When dispersants are applied, it can mix again, or it can be eaten by the microbes in there. And so when the microbes or any of the animals that eat the oil, or any animals that eat oil, and their fecal pellets are released, they can actually sink down to the seafloor and put oil on the seafloor. One scientist found the Mississippi River is right there near New Orleans, and during the time of the oil spill, it did have a heavy outflow. And so with this heavy outflow came a lot of sediment and clay. And so any of that sediment that was introduced to the oil, if it attaches to the oil, again, it makes it heavy and sinks, causes it to sink. The deep sea kill, so at the beginning of the oil spill, they actually tried to cover up the oil with different types of ideas that they had that weren't necessarily what they worked out how they wanted. And so one of the ideas was to try to top it with sand, stuff sand back into the well to try to keep the pressure out. And so what they called it was they called it the deep kill. And so some of that sediment, it didn't work. So some of that sediment that came out with the oil already, and it just basically directly sank onto the seafloor. And like I said before, when you burn oil, there are byproducts, and that byproduct sinks. So that's another resource, or another way that oil got to the seafloor. And then, as I said before, on the beaches, if it mixes in with the sand or any of the nearshore environment that has sand and clay materials, it will also cause it to sink. And on that note, I'm going to introduce Chris, who is now going to talk about the impacts of the oil on the wildlife in the area.